Okay, so this is our third lesson, third day on section 1.6. If you have not seen the other two, you need to go back and watch those. Today is the special cases when you're doing absolute value inequalities. By far, this is the easiest of the lessons. So there's two special cases. There's no solution and all real numbers. And you barely have to do any work at all in order to recognize these and get your answer and then just move on. So these are the best. Before we get too far into it, I want to review the concept of absolute value in general. So again, with numbers, if you have the absolute value of -7, or let's say you had the absolute value of, oh gosh darn it, I'm just trying to get a straight line. Or let's say you have the absolute value of +7, absolute value turns things positive. If it's negative, it turns positive. If it's positive, it stays positive. When you have an absolute value of a variable, you don't know what that variable is, so that variable could be a positive number or that variable could be a negative number. That's why the equations get set into two separate problems and you have to work them both out. But here's the deal, we're not doing absolute values equal things, we're doing greater than or less than, so we're doing inequalities. Is it possible for an absolute value to be less than a negative number? Well, no. Absolute values turn things positive. So if I say the absolute value of a variable is less than a negative number, I am presenting you with an impossible scenario. It cannot possibly happen. What if I present you with a scenario where an absolute value is greater than a negative number? Well, absolute values turn things positive. So of course, positive numbers are greater than negative numbers. That's common sense. So that means this is always true. So what we have is this is never true. That's like no solution. This is always true, all real numbers. So I have it written here. You do have to isolate the absolute value part. So if there's extra numbers or things outside of the bars, you have to go through some steps to move them over to the other side. But if you have an absolute value greater than a negative, this is an all real numbers scenario. If you have an absolute value less than a negative, that is a no solution scenario. Now you might think about 0. Can absolute value of a variable be greater than 0? Yeah, that's an all real numbers scenario as well. Can an absolute value be greater than or equal to 0? Yes, it can, but the or equal to means you would actually have to still go through and solve it. It's not necessarily an all real number problem, possibly. Can an absolute value be less than 0? Well, less than 0 is just another way of saying negative, and absolute values cannot be negative, so this is another no solution scenario. So that's basically what you have to remember, and it's pretty well common sense. So most of these problems are not going to take any work at all. They're going to start very simple, and as I go, they'll get progressively more difficult, seeing more steps and things that you have to do as we go. But it's not going to be tough. So number 2, absolute value is less than, and it does say or equal to, that's irrelevant. Can a negative number be less than, can an absolute value be less than a negative number? Absolute values are always positive, therefore no. This is a no solution. With a no solution, there's nothing to graph. You leave your graph blank. Number 2, no solution. Number 4, absolute value of n is greater than or equal to -5. Absolute values are positive numbers. All positive numbers are always going to be greater than -5. Therefore, this is all real numbers. What does a graph of all real numbers look like? You shade the whole graph. It's that simple. If you're less than a negative, it's no solution. If you're greater than a negative, it's all real numbers. The or equal to is irrelevant. You don't even have to think about that. The only thing is, you get into a problem like this, and how are you supposed to process it? Well, for this one, we do have a number outside of the absolute value bars, so that changes things a little bit, or potentially. You do have to isolate the absolute value part. So I need to isolate the p over 5 part. I'm just going to rewrite it here to give myself room. I say that on every problem. Why don't I just quit it? Okay, so I'm going to add 9 to both sides. Absolute p over 5 is less than or equal to -1. Now I can stop. Is it possible for an absolute value to be less than -1? No. You might be saying, well, Haskell, what about the over 5? That's inside the bars, so that's irrelevant. It's still the fact that we're trying to say that a positive number is less than a negative number, which is impossible. No solution, no graph. Check number 6 here just to make sure. No solution, no graph. Number 8. Absolute v plus 8 minus 1 is greater than -3. Again, we do have a number that's not inside the bars, so I do have to add it to bring it over to the other side. Absolute v plus 8 is greater than -2. I've isolated the absolute value part. Remember, absolute value is always positive. Are positive numbers greater than -2? Yes, every positive number is always greater than -2. So this is an all real number. The whole thing gets shaded. What about the plus 8? Doesn't matter. As soon as you see an absolute value isolated and it's greater than a negative, all real numbers. So there it is. Could you go further and split this up and work it all out? Yeah, you could. And you'd go through another page worth of work, and then when you're all done, you would come to the conclusion that it's all real numbers. So why do that? Number 10. Okay, look, no negative number. Maybe this isn't a special case. Maybe it's something we got to work out. So let's go ahead and do it. 3 plus absolute n over 6 is less than or equal to 1. Okay, first things first, I got to move the 3 over to the other side. So minus 3, that cancels out. Absolute n over 6 is less than, okay, what's 1 minus 3? That would be -2. Well, now we have a negative. Can an absolute value, which is by definition a positive number, be less than a -2? No, it is impossible for a positive number to be less than a negative number. This is no solution. Why did I write it out in words this time instead of the symbol? I don't know. But no solution, no graph. Oops, didn't mean to do that. Number 10. No solution, no graph. So this one didn't start with a negative number here, but after one step, there was a negative number there. So yeah, still a no solution. Is it possible that you might start with a negative number here, but after a couple of steps, it becomes positive? Yeah. You shouldn't look at this and automatically say no solution or all real numbers. The other steps could affect it. So that's why I said before, isolate the absolute value part. You have to go through those steps first. So in this problem, let's see, I don't want my bars to look too much like that one. Okay, I'm going to add 1 to both sides. 2 absolute -a plus 3 is less than -4. This is 2 times, so you have to divide by 2. I get, well, shoot, I'm writing too big. I get absolute -a plus 3 is less than -2. Can an absolute value be less than a negative number? Can a positive number be less than a negative number? No, not possible. No solution, no graph. Number 12, let's check. No solution, no graph. There it is. Number 14. So it looks like I'm just doing a bunch of extra problems here. There are some little tricks and complications that pop up, so it's worth the effort. Here goes. Okay, so we need to isolate the absolute value part. I'm going to minus 5 on both sides. -3, absolute p is greater than 25. No, 24. Stupid. 9 minus 5 is 4. Divide by -3. Uh-oh, now we have our special thing going on here. Special rule, we are dividing by a negative, so we have to flip the sign around. We get absolute p is less than -8. Absolute value less than negative number. That's not possible. This is another no solution, no graph. By the way, if you forgot to flip the sign around, you might think this was all real numbers and get this one wrong. So watch out for that when you do your homework. No solution, no graph. When you divide by a negative, flip the sign. All right, number 16, and we are done. Okay, so we need to isolate the absolute value part. So the first thing we're going to do is subtract 2 on both sides. -7 absolute r is less than or equal to 14. Divide both sides by -7 since that's times. Cancels out. I get absolute r greater than or equal, right? Divide by a negative, flip the sign. That's what's happening here. So you got to flip that around. 14 divided by -7 is -2. Absolute value is greater than or equal to a negative number. All positives are always greater than all negatives, so this is a all real numbers answer. And the whole thing, oh, it won't let me highlight. Oh well. The whole thing gets shaded. I bet this crashed again. Yep. Gosh darn it. Sorry about this. Well, at least now I can use my highlighter. So this should be all real numbers, the whole graph shaded, and there it is. Okay, so simple assignment. It's long, but look, all the answers are either all real numbers or no solution. You just got to go through the steps, figure out which is which. Do show your work. Obviously, in a problem like 2 and 4, there's no work to show. I mean, you just look at it and know the answer. The others, if you have a little bit of work to do, make sure you show your work here. As always, grade your papers. Include that when you turn it in. If there's anything confusing here, you have any questions, please contact me through email, through comments. I can answer through email. I can do a Google Meet with you if you want, whatever the case may be. So this concludes 1.6. The next thing we have is a practice test and then a test. All right, talk to you later.